All right, previously we had you have a take-home problem. And it was we were in 4.3, and it was to graph 4x to the 1/3 minus x to the 4/3 equals f of x. And it was worth noting, you can factor out x to the 1/3. We get 4 minus x as a remainder there. And so we set each of these equal to 0, and we find x equals 0 and x minus 4 equals 0, and thus x equals 4. These are roots if we set it equal to 0. So we've got the origin and we've got 4, 0. If we look for the y-intercept by setting x equal to 0, we get back to a point we already had. So we've got two intercepts on the axes. Now what? Anybody got any ideas on where to go from there? What was the next thing we did with this kind of stuff?
Do we get the second derivative, like the prime?
Yes, and what were you going with?
Oh, like, oh, we're gonna have to plot them down on like a. I forgot what it's called. Sign chart.
A sign chart, yeah.
Yeah.
So those kind of go together. We need to, we don't want to do the sign chart yet. Well, I guess we could. Let's do sign chart. And then we'll hit the derivatives. You said second derivative, maybe we should start with the first derivative, but definitely, let's get them both. So I'll look at maybe like -10, I'll look at 1, 1's nice in the middle. I didn't draw it in the middle because 2's in the middle, but. So this, what will this sign chart tell us for f of x? It does tell us stuff. If I do this sign chart, think about it while I'm going through the sign chart. I've got, oh, this is not pleasant. -10 to the 1/3, and then 4 minus -10. That's a negative, that's a positive, that's a negative. If I stick in 1, I get 1 times 3, that's a positive. If I stick in 10, I got cube root of 10 times 4 minus 10, that's a negative. What does that sign chart actually tell us? We didn't talk about it. I talked about what the sign charts for the derivatives tell us. But I didn't say what the sign chart for the function tells us. What does it tell us? Any ideas, anybody? Including viewers at home? Preston. Concavity second derivative. But it was worth taking a shot. Slope is first derivative. Concavity second derivative. What's the function tell us? Dalton? It's exactly what it tells us. This is telling us whether f of x is greater than 0 or less than 0. And so, like, we're going to have something going like this. If this, I didn't, well, we know where the x-axis is. The x-axis was at 0, 0. we're gonna have something like that. Now, where the humps are, what's going on, we need to do our derivatives to see that, but it definitely tells us we're gonna be above it between 0 and 4 and below it on the outsides. Not a good job. I like that. Not intuitive for everybody. What's the first derivative here? Let me rewrite F where we can see it better. It's way up there, kind of hidden. So we bring the power down and lower the power by 1. Bring the power down, lower the power by 1. And so we get 4/3 x to the -2/3 minus 4/3 x to the 1/3. If I factor out the 4/3 x to the -2/3, I get 1 minus x. Now that might have thrown some people off, at least the x part. When you factor out -2/3, what you're doing is dividing by that -2/3. And I could move that to the numerator, and this becomes x to the 1/3 times x to the 2/3. And that gives us the x to the first power. All right, so our zeros here. Ooh. What zeros do we have? Go for it, Dalton. We've got 2 critical points, but not both of them are zeros. No. It's worth a try. If you're not sure, set them both equal to 0. I can multiply by 3/4 here, and I get x to the -2/3 equals 0. That's 1 over x to the 2/3 equals 0. That doesn't happen anywhere. But x equals 0 is a critical point. Here we have it nice and easy. X equals 1 is one of the zeros. Any questions so far? Are we having fun yet? Okay, so let me rewrite that. Or I think the first form is easier when we do the next step. When we do the derivative. But this one allows us to do our sign chart. So like -10, fuck, 1/2, 10. Not a lot of room to check shit there. But thankfully, we're just looking for signs. We don't need the actual value. That is 4 over 3 times the cube root of x squared. That first part, and then 1 minus x. That might be a little bit easier to figure out what the sign is going on. Doesn't really matter what we plug into this first term. It's always positive because the x squared is squared, gets squared. So we have a positive and then -10, 1 minus -10 is 1 plus 10. That's a positive, so this region's positive. Same with the 1/2, positive and positive. And we stick in 10, we get a positive and a negative. 1 minus 10 is -9, so that's a negative. So we have increasing region, decreasing region. So it looks like we have at least a relative max at x equals 1. Because it's making something like that there. Now the 0, it's increasing, so it might be doing something like that, like x cubed does. Probably is. So my guess would be right now we've got 0, 1, and 4. We know it crosses at 0 and 4. It looks like I'm thinking it does something like this, hits a max at 1, comes down and does something like that so far. But let's check concavity. And we'll be able to get a little bit better picture. F double prime of x. We bring down the -2/3 and we've got -2/3 times 4/3 is -8/9. X to the -5/3. And I bring down the 1/3 there, I've got -4/9, x to the -2/3. And if I factor out the -8/9, 4/9, x to the -5/3, we'll have a 2 minus x. Again, if you're not sure how that comes about, divide each of these by that x to the -5/3. Oh, that's a plus. I had the sign wrong, look at that. All right, so this is -4/9 cube root of x to the 5th. 2 plus x. So our only 0, if we set this equal to 0, our only 0 is that -2. And we have a critical point at 0 again. So let's try -10, -1, and 10. So I have the negative in front for all of them. And then when I stick in -10 into the cube root, I'm gonna get a negative number. I don't know what it is, but it's gonna be negative. And 2 plus -10 is gonna be negative as well, so that's a negative region. If I stick in -1, this is negative, but the second one is positive. So this is a positive region. And if I stick in a positive number, both of these are positive. So we only have the negative sign out front. This is a negative. So we're concave down there, concave up here, concave down there.
Is that the sign chart for
Concavity.
F double prime?
Yeah,
Why do we check on F double prime?
for the concavity,
What's that? Oh,
for the concavity. Because I don't know if this was what we had from like the first one. But it could have been doing something like this. Or there's all sorts of variations. We don't know how it's going. But now we've got a better idea. So let's put all our sign charts on one page. We had 0 to 4, and it was negative, positive, negative. F double prime. We had 0 and 1. And it was positive, positive, negative. And F double prime, we had -2 and 0. And it was negative, positive, negative. I guess I didn't do that sign, line those up very well. I saw one thing with the relative max. We saw this here, the relative max was right there. So maybe we should find its y value. So f of x was 4x to the 1/3 minus x to the 4/3. If I stick in f of 1, I get 4 minus 1 equals 3. So the relative max is actually at 1/3. And we had zeros at 0, 0, and 4, 0. And it looks like -2 is an inflection point. Oh shit, I don't know what that value is. Might need a calculator for this one. So I've got 6 times the cube root. This is, we had x to the 1/3 times 4 minus x. So the cube root of -2 times 4 minus -2 is 6. Can't be that big. 7 or so, -7. Calculator. cube root of -2 times 6, -7.6. 7.6. There we go. Exactly. Tightening in the bottom because I didn't have a lot of room. This is at -2. And it's concave up from here to here. And it's concave down here. And concave down here. Let's see what we get when we get on Desmos. Y equals 4 minus x times x raised to the 1/3 power. Weird looking. Damn. It follows that, damn near follows that fucking y-axis for quite a bit. Super close. This is almost, that's almost dead vertical there, which makes sense. We saw the derivative didn't exist at x equals 0. So we should have had a vertical tangent there. And we do. I missed that fact on my paper. I missed that. So going back to this, we said x couldn't equal 0. So for the first derivative, that means the slope is undefined here at x equals 0. Which means we should have had more of a vertical line. Like that. Yeah,
So at any point after 0, the slope is going to be positive, but it's going to be concave down.
the slope is positive up to x equals 1.
Like after 0.
Yeah, after 0, but it's concave down, which means it's still, the slope is still increasing, but it's not increasing as fast. Was that fun? Was that everything you'd hoped it would be? All right, so we had one relative max. It was x equal, or relative max was 3 at x equals 1. The max and the min are definitely the y values. That comes pretty important in, see, look at this. I put the fucking pencil there. I had it next to the paper the whole time so that I could draw in pencil before I started fucking using ink to draw my graph. And what did I do? I fucking didn't use it. Lame. So the maximums are the y values, the minimums are the y values. This comes up pretty important in 4.4, which we're starting now. 4.4 is on the absolute extremum. So definition, f of x has an absolute max. at x equals 0. If f of x equals 0 is greater than, not greater than or equal to, greater than f of x for all x in the domain of f. It's the highest point. Makes sense? Guess what absolute min says? Someone tell me the definition of absolute min. What? Yeah, what does that mean here? F of x has an absolute min. Absolute. I don't mean x equals 0. Let's say at x equals x naught. That's what I meant to say. What does that do here? If it's greater than fx, so we're matching the absolute maximum. Less than. It's got to be less than every other y value. For all x in the domain of f. So absolute max in simpleton terms, or not simpleton, but simple terms. Y's biggest value. Simpleton terms and simple terms are completely different things. One's pretty fucking insulting. So where would these occur at? Where could they occur at? We've got some wavy function like this. Where could the maximums and minimums occur? It can't be an absolute max if it's not a relative max in the first place, right? Here, if we don't have the graph, we don't know which one it is. So the critical points or relative min and maxes from the first derivative. Anywhere else? Hint. This line does not have arrows on it. Don't. The endpoints. Or endpoints if it has them. All right. So Matthew, I had my teeth pulled.
Oh, yeah. How's it going?
He knocked me out. Like he was better at doing an IV than fucking the nurses at the hospital, this dentist was. They didn't prescribe me any fucking narcotics. They prescribed ibuprofen. It took CVS till the next day, 24 hours later, to fill it. And I didn't know. I thought they were prescribing narcotics. I went and picked it up. I wasn't hurting yet, and I didn't get them. And so I fucking called the dentist office. Is obviously closed, but I got the emergency contact. I called that motherfucker at home and said, "Your people didn't prescribe it. I'm not hurting yet, but if I'm hurting at 10 p.m. and the pharmacy's closed and I can't get a hold of you, I'm gonna be pissed as hell. So let's just get something filled now." And he called in a script for a hydrocodone. I never had to take anything. No ibuprofen, no fucking nothing
At all?
at all.
I would. Yeah,
That's fucking. No, it was a little sore, but it didn't hurt. He was like fucking godsend on fucking pulling teeth. He told my wife I did a great job, but she's like, I don't know what the hell that means. And apparently my teeth just popped right out. I don't know. It's like, I don't know, pulling a nail out with a fucking hammerhead. Never used to. Still got a full bottle. Oh, not full. They don't give out a large dose of narcotics. We'll save that for a rainy day when I'm really fucking hurting. All right. So relative where the first derivative equals 0 and the endpoints. Let's take a look at some examples. We're going to look at f of x equals x squared. We're going to look at it on the region 2, 3, where we include 2, 3. And then we'll look at it on the region where we don't. And this is a little bit comically done. Obviously, that's not what it's going to look like, because the way that curve is going, it doesn't look like it's intersecting the y or the origin. But I think you get the idea. I guess I could try to do it a little bit better. That's a little bit better. So if it continued, it would go down. So f prime of x is 2x for both of them. And that has critical values at where f prime of x equals 0. So our critical points are at x equals 0, which is outside the region. We said 2 to 3. So the only possible options we have are the endpoints. On 2, 3 inclusive, f of x has an absolute max of 9 at x equals 3, and an absolute min of 4 at x equals 2. I will have your guys' exams ready to get back to you on Tuesday or Thursday. Thursday. Someone was supposed to take it yesterday in the AAC, and I haven't received an email yet, so I don't want to hand back test yet. When you get it back, I strongly, unless you like kicked its ass, go through it, see what you did wrong. Ask if you can't figure out how to do it correctly, ask someone. Ask me, take it to the math lab, ask the tutors there. Come to me on Saturday at the Mesa Center. I'll walk you through what you did wrong on the exam. I tried to make little comments on what was going wrong, but I didn't give like the full solution on any of them. Maybe I can post the full solution. That's not a bad idea. That way you can compare it to what I got. Now, one or two of the problems had other forms of doing it. And I didn't even think about doing it that way. Some students, like, I forget which one. Some students had a clever approach. And so my answer key won't have that, but I'll bring them on Thursday. What about on 2-3? Not including. What do you guys think?
There is no maximum.
There is no max or min. That's an interesting thought. Why do you come up with that?
Because you can say it goes through the whole.
Here's a good way of saying it. Let's say, assume max is at maybe 2.999 with f of 2.99 being the max. What about 2.9991? When we square it, that should be a little bit larger. And in fact, any value we assume to be max, we can always add another decimal place. Any value we think is the max or min, we can always add a decimal place. Yeah.
Is it just infinity?
No. Because the graph isn't going to infinity. It's approached the limit as x approaches 3 of f of x is 9. And the limit as x approaches 2 of f of x is 4. But it never actually reaches it. We just get closer and closer and closer, and it doesn't matter how close we get, we can always add another decimal. So if we said the max was 3.9999999, I could always add another 9 and be closer to 4 than the previous version. So that while it has limits, it's not going to infinity. It never actually reaches those limits. And this is because 2 and 3 are not included in the domain, so we don't actually have endpoints. There are no endpoints. The gauze was annoying as fuck though. That
Keep it in.
one day,
Huh?
one day, he was changing it every half hour.
Ah,
He gave me a bag and I was just reaching in and grabbing them and I'm like, I look like a fucking squirrel for like 2 hours. And then I finally looked at the bag when the medicine, like I was fully clear headed. And I realized there were different sized gauze pads in there. I'm like, motherfucker, I've just been grabbing the largest ones and fucking folding them up and stuffing them in my mouth. And yeah, so I was like, oh boy, fucking,
how's it feel right now? Have you ate?
oh yeah, I was eating on Sunday. Not anything that was like crunchy, like I had like a burrito, like a bean burrito. So something that was soft, all around soft. But yesterday I had Raising Cane or Cane's chicken. What?
How many days to go?
The two upper ones. All right. What about? Let's give it to you. Find the max and min. Absolute max and min. For g of x equals 1 minus x squared on -1, 1. Take a few minutes, figure that out. You gotta be a sick motherfucker to work for a dentist's office. Like a real sadist. They're already digging in people's mouth and then they had to do the blood pressure thing at the same goddamn time. Those things are like medieval torture devices. You know what I'm talking about, where they squeeze your fucking arm. They've got better versions. You could do wrist and forearm now, but do they do them? Fuck no. They want it to hurt as much as possible. Some real sadist shit. Give you one more minute. For those of you that didn't get the grade you wanted on the exam, which is probably most of you. The thing that hurt you the most overall for most students was the product rule. Putting the product rule and chain rule together. So on our next review day, like when we have a review for our next test, I'll probably put the review for the actual test up like I did last time, with a bunch of questions and a bunch of the answers work out. But I really want to hit the product rule and chain rule together. Use that review day to really reinforce that, because that's where a lot of the action happens in calculus, and that's where people were doing the worst. So oftentimes they were merging the two and putting them together and making them happen simultaneously. All right, so without graphing, I can find this right away. Graphing makes this really easy, but without graphing, I can do g prime of x equals -2x. I set that equal to 0, and I find that we have a critical point at x equals 0. So our possible maxes and mins, our possible extremum, are at x equals -1, x equals 0, and x equals 1. G of -1 is 1 minus 1 is 0. G of 0 is 1, and G of 1 is 0. So this is our absolute max. And we actually have two spots where the absolute min is. Absolute min happens here and here. So absolute min of 0 at x equals plus or minus 1. And absolute max of 1 at x equals 0. If we graph this, this does some shit like this. Normally the parabola keeps going. I guess I curved a little bit too much right there. Keeps going, but since we cut it off, it had endpoints. If we have a graph, looks like this. Now let's just say f of x equals x cubed. Okay. Give you one you guys know how to graph. Not just make up some fucking general wave. If we don't give it endpoints, there are no absolute extrema. Extrema. No absolute max, no absolute min. So for answer something Preston asked earlier, we don't say infinity. It's actually not a number. It's Preston, right? Yeah. We don't, infinity is not a number, it's an idea. We actually can't use infinity in calculations. It doesn't have a value. Let's take a 5-minute break, 6-minute break. I'll come back when that says 9, 10, I don't know. Take a break. Let you guys stretch, use the rest. All right, so mathematicians are really fucking proud of this. They fucking reference this theorem all the fucking time. It's called the extreme value theorem. They're so fucking excited about it. It even goes by EVT. If you hear EVT, they're talking about this. They fucking reference it a lot from here on. If f is continuous on a closed interval, a to b, f has both an absolute max and absolute min. On a to b. They're really fucking proud of this. They fucking reference it all the time. What it means is if we have a line and it's continuous, it doesn't matter what it looks like. It could do this, some shit like this. If it's continuous, it doesn't matter which one it is. There is a max and there is a min. Absolute max and absolute min. And they call it a theorem. So someone fucking did some fancy math proof to point out something that's fucking obvious as fuck if you just draw the picture, right? If you just draw the picture, it's obvious as fuck. There's a max and there's a min. This is all they are referring to. So if you hear extreme value theorem, it just means there's a maximum and a minimum. And it's guaranteed. Guaranteed. They're all fucking super excited about it. But like if you draw the picture, it's obvious. But as we just saw from that last problem we did with x to the 1/3 and 4/3, it's not always easy to draw the picture. So if you happen to know already that it's continuous, like polynomials are continuous, and I can't fucking spell continuous. There we go, continuous. If you know it's on a closed interval, it's got a max and min. That's all it says. It has to be continuous. And it has to be closed. We just saw this doing something like this. There's no max or min. Because we don't have the endpoints, it's not closed. I get that that's helpful to point out in case you didn't know. Closed is where we include A and B. And we say it's open if we don't include A and B. And we don't want some shit like this. No. Like this is continuous everywhere on its domain. But it doesn't have a max and a min. This is not continuous, but it is closed. They say it's closed if it has every value in its domain listed. That's not closed, it's got arrows. And we just got done noting that. And you guys could help reason it out in the beginning with a little bit of encouragement. The absolute max and min can occur at critical points or endpoints. Just to put it in one sentence. So let me give you another example. And I'll have you guys work through it and we'll do it together in like 10 minutes. F of x equals 3x to the 5th power minus 5x cubed on -2 to 0. So we have a polynomial, it's on a closed interval. We're guaranteed to have absolute max and min. Your job is to find them. So I'll pause it while we're big old fun. Yeah. All right, so let's find our critical points by taking the derivative. What's the derivative here?
15x to the 4th power. Minus 15x to the squared.
Yeah, when you bring this was actually a mistake I saw on several tests. People brought the power down and multiplied correctly, but then they just left no exponent. They've had like 15x minus the equivalent of 15x minus 15x here. You only subtract, the exponent only goes down by 1. So to find the critical points, what do I got to do? Set it equal to 0. So I could factor out a 15x squared and I get x squared minus 1. What are my critical points here?
0.
What else?
Positive one.
Anything else? Negative one. So. If you're not sure how to get them, set each of these equal to 0. Can we use all of those points? What? Why not? X equals 1 is not in the domain. So we're just checking x equals 0, which is an endpoint, x equals -1, and we need to also check x equals 2. Our endpoint here, our endpoints are x equals -2 and x equals 0, but we already have x equals 0 up here, so we don't need to list it twice. So putting them in order, x equals -2, x equals -1, and x equals 0. F of -2 is 3 times -2 to the 5th power minus 5 times -2 cubed. Let's see, this is -8, -32 times -3 is -96 plus 40 is -56. Did you guys get that? Okay, I'm doing this in my head. F of -1. Oh, that should be easy. We got -3 minus plus 5 is 2. And f of 0 is 0. So what is my absolute max and what is my absolute min?
Absolute max of 2, x equals 1.
Excellent.
Absolute minimum, -56, x equals 2.
Yep. Good work. All right, so one last idea here. And then I'll give you like the guidelines for 4.5. We're not like, yeah, press.
For the solution, do you have to add the x minus, or can you just put the absolute maximum?
Depends on what they're asking. Usually the absolute max and min are the 2 and the -56. They oftentimes, like in the real world, you want to know where they occur at. Like for economics, profit graph is tends to be a parabola going downward. You want to know not only what the max is, like how much money can we make, but you want to know how many units you should produce to get it. So like whether you need the X value is dependent on the question. In real world scenarios, yes, you want the X value. All right, so we can expand this a little bit. This is not in the extreme value theorem, but if f is continuous on R, or -infinity to infinity, look at endpoint behavior. Not point end behavior. There is no endpoint because it's continuous. Really, what guides this is the largest term. The largest term guides this. So we have, if we have AF of X equals AX or AN X to the N plus AN minus one X to the N minus one plus dot dot dot. Maybe A1 X plus A0, like this is our standard polynomial setup. This is the largest term. If N is even, we have two scenarios. AN is greater than 0, we get some shit going like that, where it's going up. If N is odd, or if AN is less than 0, we got some shit doing like this. So this will have a absolute min, but no absolute max. This will have an absolute max, but no absolute min. So when N is even, you're going to have one of them. If N is odd, you get some shit like that if AN is greater than 0. Or it could be, you know, shit like that. And then if AN is less than 0, and in both cases, there is no absolute max or min. On R, if they've restricted the domain, you will have it. All right, are you guys ready to take a look at 4.5? Four point five is probably one of the longest sections. Well, I don't know that it's longest to teach. 4.5 is probably going to be your longest homework section. Simply because 4.5 is an entire section on word problems. Fucking hate when it does that. It startles me. Did anyone need that up longer? Okay. So 4.5 is on applied max and min problems. Collectively, these are called optimization problems. So, steps you should do. Read the problem thoroughly and usually more than once. until you understand it. What information is given? What are you looking for? What you're looking for in these scenarios tends to be what is to be optimized. Step 2, draw a picture. Label anything that may be important. List or introduce variables. You probably have done this in your labeling. Maybe here. And then list every relation in the picture. As an equation or expression. And maybe, any variables that have values, assign them. And most importantly, identify which one you don't know. And this may be hard to label, but shows up in equations. So it may be hard on a picture, but if you have the equation, you can do quite well. And I'm going to add, I don't have this on my notes in here, but I think I need to add it. The equation you need is not always the first one you think of. This is like. Maybe I should have pointed this out before the last test. We had that ladder problem. The ladder sliding down the wall. Everybody drew a triangle. Well, most people drew a triangle. A lot of people chose to focus on the area of the triangle. 1/2 base times height, and we didn't have any information on the area of the triangle. We didn't have anything. And people were running with that and trying to solve the problem with that, and we didn't have anything that went with it. So they started assigning like dx dt to dA dt. And that doesn't work. The area wasn't like, it's hard to draw, you kind of like shade in the area for a picture. But in the equation, A is easy to identify, but it wasn't the right equation. The Pythagorean triangle formula should have been what you went with. Now, once you have all this stuff written down, if you can. Express the equation in terms of the variable you're looking for. This might require a lot of manipulation. And keep in mind, this is max min problems. So we are taking a derivative. If we had a squared plus b squared equals c squared, and we want ooh, what do we want to do here? That might not be the best example. Let me not give an example yet. Let's wait for a problem pointed out there. What I did want to point out is sometimes, I can say this, sometimes implicit differentiation is easier than explicit. Like taking the derivative of y squared versus the derivative of y, depending on the right side of the equation. Actually, I'll give the equation. We'll use that here. X squared plus y squared equals z squared. So I could say y squared equals z squared minus x squared. Or I could have y equals the square root of z minus x, z squared minus x squared. One of these is easier to do the derivative than the other. I think this is easier. In terms of derivatives. Finally, test the critical points and endpoints. Should be found and tested. I use the shape of the graph and derivatives to help with this. Everyone got that written down? We're gonna set up the next equation or give you the next question, set up, draw our pictures. And probably not be able to solve it today. We'll see how it goes. Does anyone need this up longer? If so, say something, raise your hand, because it's good. Say something. Okay. So. Farmer John. Has. Let's say 600 feet of fencing. And wants a rectangular pin. With the largest area. Find the dimensions he wants to use. Let's assume he's got plenty of land to do it on. And for some reason, even though he's got all this fucking land, he's restricted by the amount of fencing. All right, so everyone got the problem? Can everyone like? We've got sometimes doing like 1 and 2 go together, identifying what we have and what we're looking for. It says a rectangular pin, so a rectangular pin, we'll call this length. That's length. This is width. This is width. They gave us 600 feet. What is the 600 feet?
Perimeter.
It's the perimeter. So that's our given information. That's the only number I see in the problem. The other part that was given was the shape that we're looking for, so they gave us the shape. Give shape. What are we looking for?
Thanks.
We're looking for the length and the width that do what? What are we trying to maximize here? We want to maximize the area. So what do we need to do that? What equations do we have for area? Area is length times width. This is gonna really suck if we try to maximize the area with two variables. We have two variables. So to solve this, we need two equations. What other equation could we generate? Especially keeping in mind with what we have given. Any ideas, folks at home?
The perimeter.
Perimeter, what's the equation for a perimeter of a rectangle?
2 lengths times 2 widths.
2 length plus 2 width. And we know from this that it equals 600. So let's use that. We've got the 2L plus the 2W equals 600. I can divide by 2 and I get L plus W equals 300. And let's solve for L. L equals 300 minus W. I can now make my area equation L times W now becomes 300 minus W times W. Or A equals 300W minus W squared. So we can do dA dW. (300 minus 2W). If I want a critical point, I set this equal to 0. I get 300 equals 2W, or W equals 150 feet. That's a critical point. Do I have endpoints? Or better question, what are the endpoints? What's the largest and smallest that W can be? Dalton?
0 and
0 is 1, 600, no. Because remember, we gotta have W on both sides. 0 and 300. We're restricted between 0 and 300. And if we have either of those, that is a rectangle of no length. Length equals 0. We didn't save any fencing. Right? If we think about it, we didn't save any fencing if we have 0 over 300. Because what's left over for L equals 0. If we use either of those for W. Which means area equals 0, and that's not what we want, right? So those are mins. So if we have a max, it's the critical point. So let's check our sign chart. Maybe check 100 and 200. If I stick in 100, 300 minus 200 is 100. This is positive. Or this is the first derivative that we're looking at. And if we stick in 200, 300 minus 2 times 200, 300 minus 400 is negative 100. So this is negative. So we're doing that. And it looks like we've got a max. We can verify that it is actually included. It's not like does not exist point by the second derivative. dA dW or d squared a dW squared. Take the derivative of 300 minus 2W. This is ddW of 300 minus 2W is just negative 2. So this is concave down everywhere. Which confirms that it's max and it exists there. We don't have a problem with its derivative there. So what are the answers to my question? Bring the question back up. What's the answer here? Tell 'em. Length and width are both 150 feet. You are raising your hand and all I can see is your silhouette and it's right behind you. So I almost didn't see your hand go up. That's right. For this problem, that's the answer. If they ask the area, we should include that too. Area is length times W or 150 feet squared. Max area is 22,500 square feet. Or you can put feet squared, but you should have the units. Almost always, you're gonna have units for these things. And that's 10 o'clock. Let's wrap that up. We will do a lot more of these on Thursday. I will see you then. GTFO, get the fuck out. Have a good day. Bye, folks at home.